Welcome back, chemistry fans. Going to start the free response, the fill in the blank portion of your Unit 2 exam. So we got 3 questions we need to go through. Let's get rolling on it. Let me share my screen with you. And here we go. The first question was the one that most people struggled with, even though there was a hint in this one. It is basic algebra. So you've got 2 different equations. You have x plus y is equal to 100%. Now, here's one of the tricks of this one. If you leave it as 100%, you'll find that your problem is a little bit more challenging. So what we need to always do with percentages, and I've tried to remind you of this one, is turn them into decimals. And so in this case, it'd be a 1.00. Okay, then on our second one, what we have is the 69 is the mass number for one of the galliums, and 71, times x value times, that's the same percentage that we're looking for, plus 71 times the same percentage here is equal to 69.7. Okay, so what we have is 2 isotopes. There's one that weighs 69, there's one that weighs 71, and they are not in equal proportions. They're not 50-50. If they were in 50-50, this answer would have been 70 as our answer. It's not. So it's a little bit more in the favor of the 71 or something like that. So we're trying to figure out what the percentages are here for these. It's a system of equations. So what we've got to do is substitute one in terms of the other. So what that means is I'm going to solve for x on this first equation. So I've got x is equal to 1.00 minus y. All I did was I moved the y to the other side. Let me change my pen color so you can see that. All I did was I subtracted y from both sides. That cancels out. And now I have 1 minus y. So now what I have is an equation that has the value of x. X is equal to 1 minus y. So I can come over here and I could substitute 69 is times 1 minus y plus 71y is equal to 69.7. So all I did was I substituted. And I hope that that makes sense to you at this point. Your algebra skills are coming back to you where we substitute one for the other. Now we got to combine so that we can solve for y, because now I just have an equation with 1y. But we've got to distribute here. So I've got 69 minus 69y plus 71y is equal to 69.7. So I can combine that. 69 plus 2y equals 69.7. Well, now I got to get the other side, the value to the other side. So I'll subtract 69 from both sides. And that's going to leave me with 2y is equal to 0.7. So I'm going to divide both sides by 2. And what I'll end up with is y is equal to 0.7 divided by 2, which is 0.35. That's one of my percentages. That means 35% is y. Well, if I have 35% y, that means that x is the other portion. It's 65%. I don't even need to substitute it in because there's only 2 parts to this equation. So those are my 2 answers. X is equal to 65% and y is equal to 35%. Not too challenging when you see it solved out and you understand what they were asking you for on that one. Okay, second question. Straightforward percent composition, turning it into an empirical formula. Step number 1, convert grams into convert percents into grams. So I've got 75.7 and I have 8.74, but that means that there's a portion of oxygen that's not given to us. So we have to figure that one out. Oxygen is 15.56%, which I'm going to convert that into grams also. Now I've got all 3 values. So first step is done. 75.7 grams of C, 8.74 grams of H, and 15.56 grams of O. Next step. divide each one of these by their weights off the periodic table. Well, I give you the weights, so you didn't have to go off the, you didn't have to click off the test. Didn't have to click off the test one time. 75.7 divided by 12 is 6.308, 8.74, and 15.56 divided by 16 is 0.9725. Well, none of those are whole numbers. Now we got to divide them all by the smallest. Well, the smallest of these is the 0.97. That's equal to 1. 8.74 divided by 0.9725 is 8.98. That's 9. 6.308 divided by 0.9725, 6.5. So we're going to have to multiply all of these by 2 to turn them into whole numbers. So I would have, for my carbon, I would have 13. For my hydrogens, I would have 18. And for my oxygens, I would have 2. Okay, that's how we solve the first part. Now, part 2 says, okay, well, that's just the empirical formula. Now we got to turn this into a molecular formula. So we have to add up this weight. So 13 times 12 is 156 for the carbons, plus 18 for the hydrogens, plus 32 for the oxygen. So 156 plus 18 plus 32 is 206. Well, that doesn't weigh 412. So what we have to see is that 412 divided by 206 is 2, meaning that we need to double this formula. That is our molecular formula then. Okay, last question here deals with how are we going to figure out a page. Well, that didn't work out. Okay, I will write on here and then I'll scroll it back up. Percent compositions. So in this one, it doesn't just give you the formula, it gives you the weights already. So you don't even have to do the first step. That's the nice thing. It has a mass, it was decomposed into its elements that gave 5.217 grams of carbon and 0.9620 grams of hydrogen and 2.478 grams of oxygen. And they're saying, well, what's the percent composition of each one of these? All you got to do is divide it by what I already calculated was the total weight for you. So all you had to do was take the given amount and divide it by the total amount. Individual divided by part. So this is 60.26% carbon. 2 divided by 8.657, and you get 11.11% hydrogen, 2.478 divided by 8.657, and you get 28.62% oxygen. Okay, so those are your percentages. That was as simple as task as I could give you. Thank you very much for your time. I will follow this up with a multiple choice, or this is the end of your test if you've gone through them in order. Thank you so much. Bye-bye.